Hello everyone, I am back with a new interesting video after so many weeks. Okay, and in this video we are going to learn about physics. So I am back with a new episode of physics. So okay, in this video we are going to discuss about refraction, critical angle and total internal reflection. Total internal reflection, which is TIR. Okay, so okay, what is refraction and what is reflection? See, reflection and refraction, there is a vast difference between them. Yes, this is a normal. You know what is normal? Yes. So okay, when a light ray comes and touches the surface, it bounces back. And when light ray comes and hits the surface, it bends. In this, what is reflection and what is refraction? This is reflection and this is refraction. See, what is the difference between reflection and refraction? See, reflection is nothing but bouncing back of light. Bouncing back of light is reflection. And what is refraction then? Refraction is nothing but like bending. Yes, see here it bends. When a light ray touches a surface, it bends. So this bending of the light is called refraction. Reflection can be defined as the bouncing back of light when a light ray touches the surface is reflection. And refraction can be defined as the bending of light when a light ray of denser or rarer medium touches the surface which is middle of rarer and denser and bends is called refraction. Okay, so this is the definitions of these two. I think you have got a clear idea about reflection and refraction. Okay, then what is critical angle then? So okay, first let's ourselves introduce in refraction, because this critical angle and total internal reflection are related to refraction. Okay. This is incident ray I, this is refracted ray R, and this is angle I, which is angle of incidence. Angle I, angle of incidence, and angle R, angle of refraction, not reflection, it is refraction. Okay, so let's take some bigger diagrams such that I can explain this critical angle and total internal reflection easily. This is perpendicular, the normal will be always perpendicular to the surface. Yes, okay. This bending of light is called refraction, and this is angle of incidence. This is angle of refraction, not reflection. This is refracted ray. This is incident ray. Okay, so everything is okay. Then what is critical angle in this? There is angle of incidences and there is angle of refraction. Then what is critical angle? From where does it come? Okay, I'll explain this clearly. All these doubts. See, this angle of incidence, when you increase more, the ray will bend more. At one angle of incidence, what happens? This light ray will be on the surface. Yes, see, when you going on increasing the angle of incidence, at one angle of incidence, this will not refract, this will be on the surface. Yes, see, so the angle of incidence where the refracted ray will be on the surface of the rarer and denser medium is the critical angle. Okay, see, if it is like this, it will bend. If it is like this, it will bend. But when it is like this, it will be on the surface which is middle of rarer and denser. Yes, so this angle is called critical angle. Critical angle. Yes, the angle of incidence. See, note it down if you want, you can note it down, the definition of critical angle. The angle of incidence where refracted ray aligns on the surface which is middle to rarer and denser medium is critical angle. Okay, then what is total internal reflection? Even though in this word total internal reflection is there, it is related to refraction. Okay, so let's erase all these. Okay, this is a surface and normal is perpendicular to the surface. So we know critical angle, when critical angle is present, it will be, the refracted ray will be aligned on the surface. Then what about total internal reflection? If you increase the angle of incidence more than the critical angle, what happens? When you increase more than the critical angle, it will not go outside, just it will refract inside itself. Just it will going on refracting, it will not go outside. At certain angle, when the angle of incidence is more than critical angle, see, this is normal perpendicular. At this, if at this angle it bends, it will be aligning on the surface, then this is critical angle and this will be denoted with N. Yes, so if for this angle of incidence it is aligning, so it will be critical angle. So if you increase this critical angle, it will not go outside, it will be reflected inside itself. It will be reflected inside itself. Let's say this is the ending. So this is the total internal reflection. The bouncing, total internal reflection or TIR can be defined as excuse me, the bouncing back of light in the same media when the angle of incidence is more than the critical angle. I repeat, the bouncing back of refracted ray, not incident ray, the bouncing back of refracted ray in the same media, either rarer or denser, when the angle of incidence is more than the critical angle. If you want, you can note it down. So this is all about today's video, guys. Hope you liked it and hope you gained something from this video. So I will give a video link in the description in which you can understand. I think I have clearly understood about refraction, reflection, critical angle and total internal reflection. Yes, so that's all about today, guys. Hope you enjoyed it, and taking a leave, signing off your logical brilliance. Thank you for watching till the end.